Okay, final page. We're on the home stretch. Number 28. If a ladder, which is 25 feet in length, is leaning against a building at a 35-degree angle, what is the distance from the building to the base of the ladder? I think I drew a picture on your review of something like this that says, like, this is the building, this is the ladder, and I'm calling that bit 35 degrees. None of this is showing up because I'm doing it up there. Sorry about that. So building, ladder, 35 degrees. This is a 90-degree angle. So if we want to find, let's see, the ladder is 25 feet. What is the distance from the building to the base of the ladder? So they want that one right there. Going to use this 35-degree angle. This side is the hypotenuse, opposite the 90-degree angle. This side's going to be called opposite because it's across from the 35-degree angle. Opposite and hypotenuse is a sine ratio. So we've got sine of 35 equals opposite over hypotenuse. So I can find this by multiplying both sides by 25. So I'm going to take 25 sine 35 and I get 14.33 stuff. They don't tell us what to label or how far to go. So let's do hundredths place just for fun. So this is tenths and then hundredths. Instead of staying at the 3, I'm going to go up to 4 because this one is 5 or greater. So I'm going to put 14.34 feet from the building to the base of the ladder. Okay, problem 29 says, in the picture at right, what is the angle of elevation of the ladder? The angle of elevation is formed by the ladder and the ground. So we're looking for that angle right there. We have a 90-degree angle and they've given us 2 sides of the triangle. In reference to this angle, this side is opposite. And since this one's opposite the 90-degree angle, it's always the hypotenuse. So I'm going to use a ratio that includes opposite and hypotenuse. That is sine. And I'm looking for an angle measure. When you need the angle, you need to use the inverse trig ratio. So I'm going to find sine inverse of opposite over hypotenuse, 30 over 40. This is calculator work. Sine inverse, 30 over 40. I ended up with 48.590 things. They don't tell us what to round to either. Let's go ahead and use the hundredths place, 48.59 degrees. All right, number 30. You decide to make a patio out your back door. It will be rectangular in shape with the dimensions 20 feet long by 15 feet wide. Okay, I'm going to make a picture here. It's a rectangular patio, 20 feet, 15 feet. In order to make sure that you truly have a rectangle, you read in How to Build a Patio book that the measure of the diagonals must be the same. What must the diagonal measure be to the nearest tenth to ensure that the patio is square? So they want us to find the length of this diagonal. Now because it's a rectangle, we have a 90-degree angle right there. So we've been given 2 sides of a right triangle. We should be able to find the third side. The third side in this case is the longest side, the hypotenuse. So I'm going to call it, we'll call it x, and we can use Pythagorean theorem to find this. So I'm going to take the 2 legs, square them, find their sum, and set it equal to the hypotenuse squared. 15 to the second power is 225. 20 to the second power, I think it's 400, but I'm going to check just to make sure. It is 400 equals x squared. 225 plus 400 is 625. I feel like that might be a perfect square. So in my calculator, I'm going to take the square root of 625, and it is 25 times 25 is 625. So we had another Pythagorean triple, didn't we? It's going to be 25 feet is what we need there. 20, let's see, 15, 20, and 25. If we divided all of those by 5, this would be our 3, 4, 5 triangle, wouldn't it? All right, almost done. Yay. Let's try this. Fill in the blank with the correct geometry vocabulary word. 2 adjacent supplementary angles are also what? Supplementary means that they add up to equal 180 degrees. Adjacent means right next to each other. So it could be 2 angles like this. So they are also a linear pair. 2 angles whose measures sum to 90 degrees are what? Supplementary was 180, 90 degrees is complementary with an E. I won't dock you for spelling, but it's not like paying a compliment to somebody, that's a different type. Okay, 2 angles whose measures sum to 180 are, we already have that, supplementary. 2 triangles that are similar have blank angles and sides that are blank. If triangles are similar, then they have congruent angles and sides that are proportional. Some of you want to say different, which may or may not be true, but it's not reflecting exactly what relationship they have. Proportional is the word that we're looking for there. They'll have, let's see, ratios of side lengths that would be equal to each other, so they're proportional. An altitude of a triangle is always blank to the base. So let me draw a picture. Here's some triangle, here's an altitude. For it to be an altitude, it has to hit at 90 degrees, and the word for that type of intersection is perpendicular. Okay. Good luck on the test tomorrow. I think one thing that the review didn't have that I think would be handy is if you had a triangle that you had to solve, it's 90-degree angle, and they gave you 2 sides, and you had to find the 3rd side. So it could be like this. You would have to find the 3rd side and the missing 2 angles. We didn't get a problem like that in the previous thing. You could use Pythagorean theorem to find this missing side, but do you know how to find the missing angles, or one of the missing angles? Let's just go ahead and try this one just in case. So suppose we want to find this angle. This side is the hypotenuse. This side is adjacent to this angle that I've circled. So the ratio that uses hypotenuse and adjacent is cosine. And since I want the angle measure, I'm going to use the inverse trig ratio. Inverse of cosine, adjacent over hypotenuse. Calculator work. Cosine inverse 3/5. That'd be 53.13 degrees, we'll say. Once you know one angle measure, you can use the 180 minus 90 minus 53.13 to find the other angle measure. Or we could look at this one and say, okay, this is still the hypotenuse, but now this side is opposite. So we could use sine inverse of 3/5 to find that missing angle over there. Either way that we do it, we should come up with the same correct answer. Pythagorean theorem would help us find that side. So just wanted to mention that too. Good luck on the test tomorrow.